Okay, guys, let's get into part 2 of mini quiz 4. So this looks like problem 22 here. So here's the idea, guys. On this one, notice they gave us the information. They took a random sample of 230. They took a random sample of 341. In the 230 population, 94 opposed. In the 341 sample, 147 opposed. Once they give us all that information, since we're comparing those two, we know it's a two proportion test we're going to do, right? So everyone's got to know that we use the stat button and we go over the test. Remember, if we leave it at edit, that's where we can do our lists. If we go over to calc, that's where we could do some calculations like do one variable stats and find mean, median, mode, and all the 5-number summary stuff, right? But we're going to go over to test and notice right here, choice number 6 is our two proportion. Why is it 2? Because we're comparing the two proportions. And remember, proportions, guys, when they satisfy the condition, will always be a z. They will never be a t like a means possibly could, or most likely will. So once we select 6, notice we simply put in our information correctly and carefully. Now here's the key thing. Notice we were not suspecting whether one was better than the other, right? So therefore we're going to select not equals. And then we're going to calculate. So it was a two-sided test because we didn't know if one was less than or greater than the other ahead of time, right? And here's our results, guys. Notice our p-value came out to be almost 60%, 0.595. That is a lot larger than 5%, right? So 0.595, do you agree, is greater than 0.05. And therefore, we fail to reject. In other words, not enough info. Or not enough evidence. Sorry, I misspoke there, right? And so let me remind you is when the p-value is too large, you're going to fail to reject, which means you don't have enough evidence. If the p-value was really small, then you would reject the H0, and you could conclude that you have enough evidence to prove what you want, okay? So based upon those results, we know, first of all, remember how I kept coaching you? You hopefully notice I'm eliminating answers, right? Because it's asking, is there enough evidence? No, we failed to reject, not enough evidence. So automatically, can I not cancel out the yeses? So I'm now down to a 50-50 guess. Now, which one sounds better? Well, let's look at D. It's no, because the probability of observing a difference at least as large as our sample differences were, where the two populations are the same, is greater than 0.05. That's exactly what we got. So that's why the choice was D. Notice E says less than. No, if it was less than, again, we would have rejected and we would have enough evidence. So without a doubt, it's choice D. So guys, without a doubt, that one should have been a straightforward one if you gave it an honest shot. Now let's look at 23. Now this one's kind of evil, guys, because we haven't honestly done a lot of box plots in here. Why? Because I didn't want to waste our precious time doing a lot of box plots. But here's the one thing I want you to remember. Box plots will never tell you all the numbers, right? How do I say this precisely? Remember, I don't know how many golfers are in each tournament, okay? How many golfers are here or here? I don't know. What I do know is what the minimum score was. I do know what the maximum score was. I do know what the middle score was, the median score. I do know what the Q1 score was. Remember, that would be at the 25% level. I do know what the higher Q3 scores were at the 75% level. Remember, median is 50%, right? So I know percentage-wise where everyone is, but I don't know how many people. Like, for example, Tournament 1 may have had more golfers. So this middle 50%, there may have been, let's say, 200 golfers. But in Tournament 2, let's say they had less golfers, right? Or, no, let's say they had actually more golfers. From here to here, my middle 50% scores could have involved 250 golfers. So you don't know the raw numbers, in other words. You just know the percent rank of 5 key positions: max, min, median, Q1, and Q3. Okay? So hopefully that's clear. All right, so now, anything, and that's the common trick, by the way. They try to get you and think of raw numbers. So let's look at our choices here. Let's just go in order here. A, more golfers played in Tournament 1. That's exactly what I was talking about. We don't know. More golfers could have played in Tournament 2. We just know the percent breakdown. Hope you understand. Please discuss this with me if you still are confused by that. So we know A is a trick answer. Let's look at B. B says in both tournaments, at least half the golfers completed the tournament with a score less than 288. So let me clean this up a little bit here. Where is 288? It's right here. It's saying at least half the golfers completed a tournament with less than 288. Well, remember, guys, we know that 50%, the 50% golfer is right there. That means 50% of the golfers are here and 50% of the golfers are there, right? The 50% golfer is the person or the golfer where 50%, it could have been, again, it doesn't matter the numbers, but let's say there's only 20 golfers. That means 10 golfers were below him or her, 10 golfers above him. So there's 21, let's say, right? And that's the idea, is it means a percentage. So you know what, guys? That one is pretty valid. So if I had to guess right now, I would go with B, because notice 50% of the golfers were here or less than that score. 50% of the golfers in Tournament 2 were here or less than that score. So it says at least half the golfers completed tournament with a score less than 288. That's valid. That's a good answer. Now, guys, please remember to always check the other answers, though. Let's look at C. The number of golfers who completed Tournament 1 with a score less was greater than the number. Again, see how they're converting it to number of golfers. Literally. You can't do that. Okay? Just for clarity, let's say Tournament 1 had 300 golfers. Tournament 2 had 400 golfers. Okay? This 50% mark is the 150th person, basically, here. Whereas here, that person is a 200th person, basically. Right? Does that make sense, hopefully? So, you can't convert the raw numbers, in other words. Okay, D, the range of scores of Tournament 1 is less. No, Tournament 1 has a larger range. See, remember, range means max minus min. So if you look at just the scores, you have to agree that Tournament 1 had a more variety of scores. Compared to Tournament 2, all the golfers were more consistent. Maybe it was an easier course or something, or a more consistent course, let's say, right? All right, so D is wrong because it's backwards. If it said more than, then that would have been true. E, the score of the golfer with the least score in Tournament 1, that would be this person right here, right, was greater than the score of the golfer with the least score in Tournament 2, which is right here. No. Tournament 1 had a lower score, right? So again, E was backwards. So without a doubt now, I know the answer's got to be B. Now, guys, this one we actually discussed in class. But remember, on a problem like this, you would have done the sketch. You already know, you don't know where the mean is, but you know the standard deviation is 0.5. They tell you that this score, which is somewhere over here, is at the 10% mark. So this here that I'm coloring red is 10%. So basically, you could have just gone to your calculator. Now remember, you're going to do second vars to get to your normal curve information here. And remember, we're going to select inverse norm because we know the score, we know its percentage. We want to get basically its z-score, right? We want to do the table in essence backwards. So we're going to select inverse norm. We know our area was 10%. Now, I left it, whenever you leave it at 0 and 1, guys, that means it's going to be the z or standardized score. Okay? And then, of course, our result was negative 1.28. And what that means is if I went back 1 and another 2.8 standard deviations, I would be at this value here. Well, wait a minute. We know that 0.5 is our standard deviation. So I'm going to take 1.28 times this, and I'm actually going to get this distance right in here. So here we go. If I take this times this, I get this. Now, it's negative because we went backwards. Keep that in mind. So I know if I take this 15.9 right here and I add, I know this distance from here, see, is negative 0.64, but that's going to the left. If I go to the right, that absolute value is 0.64, right? So I'm going to add 0.64 to that, and that's how I know it's 16.54. And when I look here, you could see the only one that's really close is 16.5. Guys, please discuss any of these problems with me, and obviously watch and study each of these problems one by one in the video. And good luck on the final. See you in class.